Now that we're moving into Domain 2, Security and Compliance, let's start with one of the most important foundational concepts in all of AWS, the Shared Responsibility Model. The AWS Shared Responsibility Model is essentially a framework that explains how security and compliance tasks are divided between AWS and the customer. And this is something AWS takes very seriously, because when you move to the cloud, you're not giving up control, you're gaining flexibility while reducing operational overhead. So here's the big idea. When you use AWS is responsible for protecting the infrastructure that runs all of the cloud services, while you, the customer, are responsible for securing what you put inside the cloud. AWS calls this security of the cloud. AWS takes care of this. Security in the cloud. The customer takes care of this. Let's make this more concrete. Security of the cloud refers to everything AWS manages behind the scenes. This includes things like the physical data centers, the servers, networking equipment, the hardware, and even the software that makes the cloud run, like the virtualization layer. You never have to think about securing a data center, patching a physical server, or worrying about fire suppression systems or building access. AWS handles all of that globally at massive scale. Security in the cloud, on the other hand, is the customer's area of responsibility. This includes your data, your application configurations, your identity and access management, your guest operating systems, and how you architect your solutions. For example, if you misconfigure an S3 bucket and make it public, that's on you, not AWS. If you choose weak IAM policies or forget to enable encryption for your databases, that's part of your responsibility. What's powerful about this model is that it balances responsibility. AWS removes the heavy lifting of infrastructure security, but you stay in full control of your applications and data. This gives organizations the freedom to innovate quickly while still maintaining strong security and compliance postures. And as we'll see in the next slides, there are responsibilities that belong only to customers, responsibilities handled entirely by AWS, some shared responsibilities, and even cases where responsibility shifts depending on the service model. So, let's break each of these areas down in more detail. Let's break down what customers are specifically responsible for when using AWS. Even though AWS takes care of the global infrastructure, customers still have important responsibilities, especially around their data and their operating systems. Let's start with those two. 1. Customer data management. One of the most important responsibilities you have on AWS is protecting your own data. AWS gives you secure storage services like Amazon S3, EBS, and RDS, but what you put inside those services and how you secure it is entirely up to you. This includes things like data classification. You decide which data is public, internal, confidential, or highly sensitive. For example, customer PII or financial data should never be publicly accessible, and that classification determines how you secure it. Access permissions. You manage who can access what. If an S3 bucket becomes public accidentally, that's the customer's responsibility, not AWS's. Encryption. You choose whether to encrypt your data at rest or in transit. AWS provides the tools, like KMS, but you must enable encryption and manage the keys if needed. Lifecycle policies and retention. For example, you decide whether old log files move automatically to S3 Glacier or get deleted after 30 days. Backup and recovery strategies. AWS gives you the tools, such as Amazon RDS snapshots or S3 versioning, but the decision to back up your data and how often is your responsibility. Think of it this way. AWS protects the storage system, but you protect the content that lives inside it. 2. Operating System, OS, Management. The next major responsibility customers have is managing the guest operating system, but this depends on the AWS service you're using. If you're using Amazon EC2, you are responsible for everything that happens inside that virtual machine. That includes installing security patches, applying OS updates, managing antivirus or endpoint protection, configuring firewalls, such as IPtables or Windows Firewall, hardening the OS, like disabling unused ports, services, and accounts. AWS handles the underlying physical host, but you manage the OS layer on top of it. For example, if there's a critical vulnerability in Linux or Windows, and your EC2 instance gets compromised because you didn't patch it, that falls on the customer. But what about managed services? On the other hand, when you use managed services like AWS Lambda, AWS Fargate, Amazon RDS, AWS takes over the OS responsibilities. You no longer patch the OS. You no longer worry about antivirus. You no longer manage the underlying runtime environment. AWS handles everything below your code or your database configuration. This makes managed services extremely attractive for security and operational efficiency because your responsibility is reduced. So in short, if you control the OS, like on EC2, you manage it. If AWS controls the OS, like with Lambda or RDS, AWS manages it. In the previous slide, we talked about managing your data and, depending on the service, managing the operating system. But your responsibilities don't stop there. You are also responsible for securing your applications and controlling who has access to your AWS environment. Let's break these down. 1. Platform and application management. When you build or deploy an application on AWS does not secure your application code for you. That responsibility stays with the customer. This includes several important tasks. Managing your application code and dependencies. If your app uses a library with a known vulnerability, AWS won't detect or fix that for you. You must keep dependencies up to date. Runtime configuration. Environment variables, API keys, database passwords, app-level encryption keys. You must store and protect these correctly, usually with tools like AWS Secrets Manager or Parameter Store. Patching application frameworks. For example, if you're running Node.js, Django, Spring Boot, WordPress, you must keep these frameworks updated. Securing your APIs. That means using API gateway throttling and authentication, IAM authorization when appropriate, Cognito for user access, WAF to protect against common attacks. AWS secures the cloud infrastructure, but you secure your application running on top of it. Example: if your application is vulnerable to SQL injection or you push buggy code into production, AWS is not responsible for those issues. Those fall under customer-side security. 2. Identity and access management, IAM. Now let's talk about one of the most important responsibilities, identity and access management, or IAM. Even though AWS provides the IAM service, you decide how it is configured. This includes creating IAM users and deciding who has access. Using IAM roles for services like EC2, Lambda, or ECS. Assigning permissions and policies. Enforcing multi-factor authentication, MFA. Applying password policies. Managing access keys and rotating them. Ensuring users only have the permissions they absolutely need. The golden rule here is the principle of least privilege. That means, give users and applications only the permissions necessary to do their job, and nothing more. Examples. A developer should not have access to production RDS databases unless absolutely necessary. An EC2 instance that only needs to read from S3 must not have full S3 access. Root user credentials should never be used for daily operations, and MFA should always be enabled. Misconfigured IAM is one of the biggest causes of security breaches in the cloud, and AWS makes it very clear. Customers are fully responsible for managing access to their AWS resources. Closing line. In short, AWS gives you the tools, but you control application security and access management. In the next slide, we'll look at even more shared responsibility areas and how responsibilities can shift depending on the AWS service you choose. All right, now let's continue with the final set of customer responsibilities in the AWS Shared Responsibility Model. So far, we talked about managing your data, your applications, and your identity policies. Now we're moving into two areas that are extremely important for securing your environment: network configuration and service configuration. 1. Network and firewall configuration. When you use AWS networking services, specifically Amazon VPC, you, the customer, are fully responsible for configuring your network controls. Think of AWS as giving you a fully customizable network, but you decide how it is shaped, secured, and connected. This includes security groups, virtual firewalls for your EC2 instances and resources. These control what traffic is allowed in and out at the instance or service level. Example: allow inbound traffic only on port 443 for a web application. Network ACLs, access control lists, subnet-level firewalls. These act as a second layer of network filtering. Subnets, public versus private networks. You choose which resources should be accessible from the internet and which shouldn't. Routing tables, determining how traffic moves inside the VPC. For example, routes to an Internet Gateway or NAT gateway. NAT gateways allow private instances to access the Internet securely. AWS provides the service, but you decide whether to use it and how it's configured. Firewall rules, controlling inbound/outbound traffic. You determine what is safe, what is allowed, and what must be blocked. Example scenario: if a security group is left open to the world, for example, 0.0.0.0 out of 0 on port 22, that's not AWS's mistake. Customers must ensure their network rules follow security best practices. This is why exams often ask who is responsible for securing VPC traffic, and the answer is always the customer. 2. Service configuration. Now let's talk about something a lot of people overlook: service configuration. Even when AWS provides a fully managed service, like RDS, Lambda, or S3, you still decide how that service is configured. And that configuration has direct security and cost implications. Here are some examples. Amazon S3. You choose whether a bucket is public or private. You enable or disable encryption. You configure lifecycle rules. A misconfigured S3 bucket that exposes sensitive data is the customer's responsibility. Amazon RDS. AWS manages the database engine patching, backups, and underlying OS. But you choose who can connect to the database, whether encryption is enabled, which subnet the database lives in, whether backups are configured properly. AWS Lambda. AWS secures the runtime environment, but you configure IAM execution role, environment variables, VPC settings, timeouts and triggers. Even with the most automated services, configuration decisions remain a critical part of the customer's responsibility. In short, AWS provides the service. You configure it securely and appropriately. So, when it comes to networks and service configuration, AWS gives you the tools, but your security posture depends entirely on how you set those tools up. Next, we'll explore AWS's responsibilities, everything AWS does behind the scenes to secure the cloud itself. All right, so at this point, go ahead and pause the video. Take a moment to read the question carefully and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer. Here's the scenario. A vulnerability is discovered in the Linux operating system running on an Amazon EC2 instance. Who must apply the patch under the AWS Shared Responsibility Model? Before you choose an answer, let's break down what the question is really asking. This is all about EC2 responsibilities, specifically, who is responsible for the guest operating system on an EC2 instance. Remember, AWS manages the cloud infrastructure itself, the hardware, the networking, the virtualization layer. But once you launch an EC2 instance, you are in control of what's installed inside that instance. Now let me give you a couple of clues to help you identify the correct answer. Think about the difference between security of the cloud and security in the cloud. Ask yourself, who controls the OS inside an EC2 instance? If a vulnerability exists inside the operating system, not in the underlying infrastructure, does AWS fix it, or is that up to the customer? Take a moment to read the options and try to identify which one aligns with the customer's responsibility for EC2. All right, let's break down the correct answer. The correct answer is, the customer must patch the EC2 guest operating system. Here's why. When you're using Amazon EC2, AWS is responsible for the infrastructure that runs the instance, the physical servers, the networking, the storage, and the virtualization layer. But everything inside the instance, the operating system, applications, libraries, and configurations, is entirely the customer's responsibility. So if a vulnerability is discovered in Linux running on your EC2 instance, you must apply the patch, just like you would in a traditional server environment. Why the other options are incorrect. AWS automatically patches all EC2 operating systems. No, AWS does not log in to your instances or patch your OS. You control the OS, so you must secure and update it. AWS handles all maintenance for EC2, including OS-level updates. AWS maintains the host hardware and hypervisor, but not the guest OS. This choice confuses infrastructure maintenance with OS management. The customer only patches applications, not operating systems. This is incorrect because both application patching and operating system patching fall under customer responsibilities for EC2. So remember the rule of thumb. AWS equals security of the cloud. Customer equals security in the cloud. And OS patching on EC2 falls squarely into security in the cloud. Great job! Let's move on to the next topic. Now let's move into the first major area of AWS's responsibilities: physical security. This is an important part of the shared responsibility model because it covers everything customers never have to worry about when they move to the cloud. When you run your own data center, you're responsible for protecting the building that holds your servers, locks, cameras, guards, power systems, cooling, and so on. But in AWS, all of that becomes AWS's job. AWS owns and operates dozens of highly secure data centers around the world, and they take physical protection extremely seriously. Their facilities include 24/7 surveillance. Cameras monitor every entrance, hallway, and server room. Security guards and controlled access points. Only authorized personnel can enter, and even they follow strict access protocols. Biometric authentication. Think palm scanners, key cards, multi-factor access layers. Environmental controls. AWS ensures proper power, cooling, fire suppression, and redundant utilities so the hardware stays safe and operational. Redundant facility design. Data centers are built to withstand failures. If one component fails, power, cooling, networking, the system seamlessly shifts to backups. The idea is simple. You never touch the hardware, you never have to secure the building, and you never have to worry about losing systems due to a physical disaster. This allows customers to focus entirely on securing their data and applications inside the cloud, while AWS protects the physical layer underneath it. So anytime you hear security of the cloud, physical security is one of the biggest components. Let's move on to the next major category of AWS responsibilities: infrastructure protection. If physical security protects the buildings, then infrastructure protection focuses on protecting the technology foundation that makes AWS work. Think of this as everything AWS manages beneath your workloads: the global infrastructure, the hardware, the networks, and the core services that allow your applications to run reliably. Let's break down what AWS is responsible for here. 1. Regions, availability zones, and edge locations. AWS designs and secures its global infrastructure, hundreds of data centers grouped into regions and availability zones. This includes redundant power and networking across ASes, fault-tolerant designs, highly available architecture, global routing and traffic management. For example, if you deploy an application across multiple ASes, AWS ensures the underlying infrastructure keeps those ASes isolated, resilient, and interconnected securely. 2. Compute infrastructure. AWS manages the physical servers and hypervisors that support services like Amazon EC2. You never patch a hypervisor. You never manage the physical hardware. AWS takes care of. Firmware updates. CPU security vulnerabilities. Hardware lifecycle management. Your job is only the guest operating system, the part inside the EC2 instance. 3. Storage infrastructure. Services like Amazon S3, Amazon EBS, and Amazon FSx rely on complex, distributed storage architectures. AWS handles hardware reliability, disk replication, durability guarantees like S3's 11.9s, failover and self-healing storage systems. This lets customers focus on how they store and protect their data, not on the physical disks underneath. 4. Database infrastructure. AWS also secures and maintains the core systems that power managed databases like Amazon RDS, DynamoDB, Aurora. They manage engines, backups at the infrastructure level, failover mechanisms, and maintenance scheduling systems. The customer only manages configuration, data, and access. 5. Networking infrastructure. Finally, AWS protects the global network backbone, one of the most advanced and secure networks in the world. They maintain data center to data center connectivity, border routers, DDoS protection systems, network isolation and segmentation, traffic routing across regions and ASes. Your job, as the customer, is limited to configuring your own VPCs, security groups, and network rules. AWS secures everything beneath that. Infrastructure protection is AWS's promise that the foundation of their cloud, hardware, global architecture, storage systems, networking backbone, and managed service engines will always be secure, resilient, and highly available. This is the plumbing of the cloud. You don't see it, you don't touch it, but everything you build depends on AWS handling it flawlessly. We'll stop here for this section. In the next video, we'll continue this lesson and move forward with the rest of the AWS responsibilities.